going to diffuse a lot of heat, I have to kick it up to 40 watts, so the solder just won't melt.
You talked about the reflow ovens at the beginning of your talk. Is there any do-it-yourself guide for or software to regulate the temperature? Because I was trying a bit and fucked up some PCBs.
There is a kit available from sparkfun.com, which is a hobbyist and electronic prototyping supply company that hooks up to toaster ovens and allows you to do some control via, I believe, the serial port of a computer, as well as having a temperature sensor in the circuit for feedback. That may give you better results than sitting there and watching it, but I'm not sure. I have very limited experience with this. I've done a little bit of reflow soldering using a hot air gun, which worked the first time and burned up the PCB the second time. So I'm not certain. There's that kit. Your mileage may vary.
I have a question. If I would like to start on microcontroller programming and I'd like to start with real basic things like flashing an LED or something, which chip would you recommend? Would you start, say, a PIC or an ARM or whatever?
AVR is a good one to start with. PICs are very, very difficult chips to program for. The only reason why they've become a de facto standard is because they're very, very cheap, and they've been used for so long that they keep using them. But when you're learning how to program for from a fresh start, I'd suggest the AVR, or if you can afford a prototype board for the PowerPC, a PowerPC 32-bit system on a chip is also a good starting point.
From my perspective, I have some experience with the AVR microcontrollers made by Atmel. This board is a development board for the ATmega 168 and the ATmega 8. It's called the Arduino. It's manufactured in Italy and has a open source programming environment and open source development toolchain based on AVR glibc, I believe. The development environment uses a language very much like C, but slightly more restricted because the chip is a slightly more restricted environment. There are a lot of very useful libraries available, including ones for doing things like writing to character-based LCD displays or controlling touch sensors. So with a very small amount of code, you can get something very impressive up and running. This board costs around $30 US and is available from, I believe, tinker.it. If it's not available there, they'll have links to suppliers. One of the suppliers in the US is sparkfun.com. The individual chips are available from any number of electronics distributors like Mouser, DigiKey, probably Conrad. They cost around $4 each, so that's American dollars. So even cheaper.
2-3 euros.
Yeah, exactly. Way to have a good exchange rate. And basically, you can flash the chips with the open source bootloader that goes on this, and then this hooks up via USB to a computer. So programming the chip is as simple as, whoops, not throwing your electronics everywhere. Programming the chip is as simple as hitting the reset button and then hitting a button in the programming environment to send the code to the chip, and then it starts running a couple seconds later. In fact, these boards used to come with an LED on them and pre-programmed with the blink the LED example.
Some of the more sophisticated bootloaders from the manufacturer will allow you to step through debug via serial port debugging. So it'll be running code through the bootloader and stepping through by almost virtualizing the application running, but really the bootloader is the primary program running and communicating via serial port. So if you don't want to get something like BDM or JTAG to do step-through debugging, look at the what functionality the manufacturer-provided bootloader might provide in that arena.
I'm going to reiterate that I highly recommend that. I built a project using that was a model of a 30-story apartment building with about 5 apartments per floor. Every single apartment could be turned on or off with a remote control. The whole thing was, I believe, a total of like 12K of code when it was all compiled, and it used 2 of those chips, one in the remote and one in the base of the tower. It was very easy to do on-the-fly modifications, repairs, get the thing running, and I learned a lot from that project as well about that microcontroller. I'm very attached to it.
Yeah, just a suggestion. If you want to try soldering and programming microcontrollers, there's the lochraster.org page, which has the blinking light board on there, a microcontroller-controlled LED light. With it, I think it's an Atmel Mega 8. It's quite famous in the club, so you might give it a try.
Mm-hmm. And the Atmel Mega 8 is also programmable with that setup, so you can go either way. Another thing that's interesting, Mitch, I've forgotten his last name, the man who was in the Hack Center.
He doesn't use his last name. He's speaking later tonight, and it's just Mitch. He's very easy to spot. He's got purple hair on one side, and he has the brain programming stuff with light and sound. Those use very simple microcontrollers, and I think he has kits that he's selling for building your own.
Those kits are a very simple development board for that microcontroller. They have a serial port that you can reprogram the controller over. So some people have been reprogramming their brainwave goggles, and if you get one of those kits, I believe it's between $40 and $50 American, I think. You have a development board for that kind of kit. And I believe the software is all free open source.
Excuse me. There's this. You said that there are some guys here who are who brought a reflow oven with them. Who are they?
The Viennese camp, I believe it's MetaLab, has a toaster oven that they've been using to reflow parts for a LED display that they're building.
Oh, and another question. After, like, I didn't really hear you say this, but like you said that there's after a workshop of some kind, or where you could.
Were we doing a workshop?
I don't remember what you said actually. It was something like that.
Mitch was doing a workshop in the Hack Center on building the brainwave goggles.
Yeah, we have some tools that we've kept down there. I've left my soldering iron and helping hands, but I haven't actually been in the Hack Center helping out. It's been pretty full.
That's what you said. You brought some tools, was it?
I have some tools with me. I have not. Well, I did a little bit of a thing at the Hack Center where I gave away a few kits for a logic analyzer and a simple logic probe. If you're looking to get the microcontroller kit that was used in the brainwave goggles, the man you want to see is Mitch, who is doing a Hacking Your Brain presentation.
I think it's later today.
Yeah, later today, I believe, in this very same room. Does that answer the question adequately? I'm not sure that I...
Yeah.
Others?
More questions?
Nope. All right, well, thank you very much.
Yeah, thank you for having us. It's been great talking.